Right. Good afternoon, good morning, good evening, everybody. Jason Fox here, back again for one last time before the winter break, and we've got even more to cover today. We won't be dealing directly with context brokers anymore. We'll start dealing with the stuff around the context brokers. So I notice looking at the chat, there are various questions which are already in there. I won't answer those directly right now. I'll find an appropriate time to cover stuff. Also, the material in this section, there is a deliberate gap to try and answer certain direct questions you may have. So that hopefully will be covered. So let's move on to NGSI LD. IoT agents. Now, the idea here is to explain what an IoT agent is, why you need them, and how they work with NGSI on a broader sense. And this is one of the questions which was asked a couple of days ago, is that you could consider other tools such as NiFi or Node-RED to be doing the same job as an IoT agent. So when you understand what the role of these elements are, you can broaden the idea and use it to get your data. The assumption, again, so far is that somehow, no matter how you've done it, you've got data into your context broker. And now this is going to show several ways you could actually do that. There are effectively three different types of context data which arrives via IoT devices. Obviously, not all context data is bound to an IoT device. We're not on that layer. We're higher up. But the easiest one to deal with, and the one we'll deal with first, is measures. And then we will move on to the idea of actuations and lazy attributes. Now, that is currently in flux. Because the context brokers are upgrading from the 151 to the 161 and coming up to the 171 interface. So there are bits which I will show which will be added in the very, very, very near future. Again, there are actually two ways you can do actuations, if not lazy attributes. You can either do it via registrations or you can do it via subscriptions. If you do it via subscriptions, what you're saying here is that your context broker is effectively a digital twin, and it holds the status of the command you want to get done, and it's down for some other component to actually change the state there afterwards. There are a few more ideas in this slide deck, which we might or might not cover depending on time constraints, but we'll certainly be explaining how we potentially could get NGSI v2 into your system if you've already got an NGSI v2 legacy broker, or you want to retrieve data from an alternative source, which is, again, this is not so much saying, you've got an NGSI v2 broker out there. It's just that you will need to use the same technique if you have another source of data out there. So let's just summarize what an IoT agent actually is. IoT agents are there to overcome a common problem in the IoT domain, in that you've got data in some sort of standard. You're using 1M to 1, you're using JSON payloads over HTTP, over MQTT. You're using a well-defined binary format like Sigfox, or you're using a standard robotics system like ROS or ROS2. All these IoT protocols have got a good reason for existing. They are either simple or quick or comprehensive, or work well in a specific domain. But the problem remains is that somehow I've got to get from that proprietary format, according to that proprietary payload and that proprietary transport mechanism, data into a context broker. Now, if you can use an existing IoT agent over your data, then the device which connects to it could be considered as Fireware ready. We have a marketplace within Fireware where we sell products which plug into Fireware systems, and if you are able to connect to an IoT agent, because IoT agents themselves are quite flexible, you have got something which is perfectly usable by external companies. You can sell your devices and say, hey, this will plug into whichever Fireware system you've got. It is perfectly possible, of course, that you could have an external device which is capable of sending a simple HTTP request with an appropriate payload. And if you've got the ability to send HTTP, and this is indeed the way I will be describing how we will use NiFi as an example, then what you can do then is, your devices can be NGSI ready as well. However, there's always the possibility that whatever exotic data format you wish to support doesn't have its own IoT agent, or alternatively, there could be one where you've got a well-known payload, but you want to use an exotic transport. Example of that, again, if you look through the existing Wednesday webinars, there was a example I gave where I was trying to pass data using a distributed acyclic graph. In other words, a blockchain, inverted commas, basically, so that the data coming in was obviously stuck, is going to be unchangeable, verified, unchangeable before I reach my context broker. Sort of thing you might want to use for, say, some sort of payments mechanism, maybe. Obviously you wouldn't want to put all your IoT data across a blockchain, but it's obviously important stuff might be worthwhile. And of course, I needed to make sure that could be supported. If you want to support something like that, you have to either write your own IoT agent, or you have to write your own proxy around an existing IoT agent. Now, that is a much simpler job than it sounds, for the simple reason that there already is this IoT agent node lib. If you can write JavaScript code, you can write Node.js code, then you can do this translation easily enough. I repeat, just for convenience, why linked data makes sense. The reason why you want to worry about linked data is that the attributes which you've got, the names you've got, the data which you've got, is not necessarily the same as the data which the rest of the data space you are trying to communicate with actually holds. It is necessary to potentially modify the data coming in. Let's say you've got a reading which is a percentage, and you want to make it a range from 0 to 1, for example, or it is necessary to change the name from TEMP to temperature, because that's what the common data models call it. So it doesn't really matter, because if you can get your data into a context broker, you can get the data into a context broker using your preferred short names and your preferred mappings of IRIs, and then somebody else can retrieve it as they see necessary. This is obviously one of the slides which I've shown beforehand, so I don't need to go into detail, but it just points out that there is plenty of cases, and of course data space is a classic example, where there is data exchange between multiple organizations. So let's just have a quick look at the what we mean by IoT agent and how we would configure it. If you look at the basic diagram of the Fireware architecture, what you will see is that IoT agents and connection to robots is all in the bottom layer, because this is going from the device layer coming up. And what the way you can set up an IoT agent is that there is a config file. It's a config file where you can describe which context broker you want to contact, what port you want to contact the context broker on, which flavor of NGSI you wish to talk. This is, obviously NGSI version LD. But for LD, there are a few other rather important elements here. Firstly, because the IT agent node library was originally developed for NGSI v2, you need to state which tenant is the default tenant, because you're not necessarily going to receive that information when you are actuating. And same with the service path, the scope, and again, not particularly useful for LD, but you could, in theory, add scope data into this system as well. When I'm saying you can configure a config file, obviously, as you would expect, this is a containerizable microservice. It is configurable using environment variables. And once again, you can set IOTA, context broker version, or fallback tenant, or fallback path, or whatever, to set these values. So it's whether you update this by persisting a volume with the microservice, or you use the environment variables, is entirely up to you. I'd use the environment variables, because that way you can configure the thing a lot more easily. You can see once again the context I've got here. Now, this was kind of covered in the session yesterday, where I'm saying is that what I would have is I would have a link to a context of well-known location, right? And within that, I would have the NGSI LD at context as defined on the bottom right of the screen at the moment. So you can see I would have my data models from example.com defined in a file, and I would also, in preference, also include the version of the core context you are dealing with. The reason for doing this is that way the data which you are retrieving at the far end is going to be fully valid Json LD. It is implied whenever you have a communication with a context broker that you will be using the core context. You wouldn't be able to use a core context otherwise. But if you wish to, say, output the data as JSON, say key values JSON, and you want to use that as JSON LD outside the context world, you would need both of those lines in there in order to deal with this. This is much easier to understand if you start playing with the JSON LD playground. And if you start playing with the JSON LD playground, you'll find that one of the things that you will need is a link to the public version of your context file. So yeah, place this onto a public server saying these are the mappings I wish to use. The core context holds all your common strings, and again, looking at the bottom right, you've got the very, very last line of the context is this at vocab. What that means is that if you don't define anything, it will define a rather useless domain for you to put your values in. The preference is obviously to reuse the existing elements of the core context where possible, and then expand using well-defined data models where possible, and then expand to alternative ontologies where possible, and then you've got a really obscure use case, that's when you have to start making things up as you go along. When you are making things up as you go along, obviously the thing to do is to raise a PR request onto, say, smart data models, so that the next person who comes along will be able to use the same terms as you have. Because at the end of the day, the reason why you are dealing with at context, Json LD, linked data, blah blah blah, is because you want to share and you want other people to do the same thing. It's important to see that there are the standard terms for your geo properties. Obviously, this means that location, which is the default for your position, is the obvious candidate for, say, the values you put into a GPS reader. So don't start putting stuff in strange places if you don't have to. On top of that, you would need to have whatever your devices in your world would have. Now, there's no requirement here that you must have literally everything which you have in your domain, just everything that you want to get from your IoT device. Obviously, different systems could offer different contexts, because if I'm not dealing with buildings, I wouldn't need it in the. If I'm just putting stuff up as devices, and I'm not dealing with buildings, I don't need building defined in this file. Now, what you'll see here are examples of the basic device smart data model, which is based off the SARF idea of a device. If that's sufficient for you, use it. But there are multiple other definitions of more complex devices, like multi sensors and stuff like that. Which obviously, if that's what you need, you can do this as well. As you probably know, we're going to be dealing with my cows again, and most of these attributes have got well-defined terms. You can see that filling level and temperature are well defined by SARF, so I'm using that already. I've got various SARF terms in there, but I couldn't find a SARF term for heart rate, which is obviously I've got a heart rate monitor. So at that point, what I do is go out there and find a relevant ontology. This is a biological ontology to say, okay, heart rate is actually this IRI. And then finally, if I've got some really custom stuff, put that at the bottom of your file. That's a bit of a tip as well. As I said, you can kind of generate most of this, but as you find that you've got an extra bit added onto your context, it's worthwhile just adding it into the file at the bottom and keeping the groupings as necessary. You'll notice that some of my values are something colon something rather than a full IRI, and that is because what Json LD will do for you is it will prepend however I've defined example. I've defined example as https example.com/data models.html/ into the IRI for you. Now, we're talking about IRIs here. We're not necessarily talking about URLs. Not all of these values will resolve to a web page. It's nice if they do, because humans rather expect that the links are for them. And if you see this data on screen, people go around clicking on it and finding out what the data is. It's not necessary to do that. It's just polite. And obviously it would be encouraged to cover it that way, so that you can, if some third party is reading your data and they don't understand what a foo is, they can look up http blah 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 /foo and find out what foo actually means. Right. We'll briefly be moving on to an example, but this is the basic data flow which we will cover. there is something going on in my device. It makes some sort of reading. It needs to somehow connect to the south port of a context broker. The way it does that is that it's configured within the device itself to somehow communicate with the IoT agent. In this first case, we're just going to use an HTTP handshake. It could just as easily be MQTT. It could be LoRaWAN. It could be whatever. The point is that the IoT agent needs to know where it's listening when it's being configured, and it needs to be set up so it understands the relevant payload. The payload is received by an IoT agent. That's some sort of event. And then based on the configuration of the device within the provisioning database of the IoT agent, it works out what the various mappings are, works out what any manipulations you want to do on the data before you push it towards the context broker, and then it pushes the update request. Update request, as you probably remember, is going to be a batch upsert probably, although it could also be just a post or a patch. This is obviously we're just getting a reading here, but it is possible to set up a reading, say, I have updated my device. My device is resting in a building. So if my device has a temperature of 25 degrees, then I can also update the building with 25 degrees. Remember what I was saying yesterday was that I want to potentially make queries across the building. I don't want to have to keep going multiple hops to find out where all my data is. Context brokers tend to, in the end of the day, offer you a very flat entity hierarchy, because that way you get what the information you need. It's the only way we can ensure that we have the state of the art at the moment, because obviously the data may be shared across multiple brokers, and then we can make the change as necessary. So, as I said, what we're going to do, this is going to be the NGSI LD. I've got the NGSI V2 there as well, just to show compare and contrast. It's just an upsert. All of the information you can see there is readily available. I've got my @context either as a header, or in this case, I put it in the body. So since I put it in the body, the content type is application LD plus JSON, and I create an attribute as I've been creating attributes beforehand. This should be nothing new. You can see there that what I've got here is a normalized payload. You could probably do this using concise, assuming your context broker can deal with it. But typically, when we're talking machine to machine, machine to context broker communication, they're happy enough to accept full normalized data. You'll notice that for a proper NGSI LD payload, I'm using the proper observe that property of a property. And you'll notice there also that both observe that and Unicode are special in that they are what's called non-reified. It means that the data is not doesn't need to have a type and a value. It's already defined as being special enough to put the data in. Whereas if you want to add in additional metadata like accuracy, in this case, you need to add in a property of a property which has got a type and a value and what have you. Obviously, if I was to be pedantic, I would state that the accuracy should also in itself have a unit code, because obviously that's that value of 1 is meaningless unless we know what the range is. So I'd probably put a unit code of C62, which is the UNCFACT code for 0 to unity, which says, I've got 100% accuracy. I'm really, really happy about it. There are also potentially other attributes which could be static attributes. So in this particular case, we have already using the basic device data model, there's a relationship defined, a relationship to a controlled asset. So this is saying this is a thermometer lying in building 1. And you can see that that's just an ordinary relationship at the bottom of the page. Let's see some of this in action. Right, where are we? Those 3,000. Not running anything yet. Let's start up a little Docker Compose. Oops, wrong one. That's not the one I want. Yeah, you can. That's later on. Where are we? So let's start up a little Docker Compose. Start. Now, it really doesn't matter which context broker you're using. I'm using Orion because it's quite quick to start up. And obviously got a small footprint, which is useful because I'm just using a machine here, a PC. But as you can see, I've got this context file, which I am somehow putting publicly on the net. I've got some sort of backing database, which I'm also using for my persistence of my IoT agent data. And that's just, but Core is just a series of devices as far as I'm concerned. So this is not particularly relevant for that, for this thing. But I've got this thing called the IoT agent. And you can see I've set up all those parameters which you would expect based on the first slide I've got there. So I'm saying I am using the so-called ultralight syntax, and therefore I'm using the ultralight IoT agent, and you'll be able to see what an ultralight payload looks like in a minute. So are we available yet? Yes, we're up and running. Okay, so as I said, I've got something running there. It's running version 224. Okay, and it's listing on port 4041 for the configuration. You can see 4041 is on the scope. So first thing I need to do is I need to create some sort of service, which is a group which is which has got common data across multiple multiple devices. You say my base name of a device an entity is going to be called device. I'm listening on that particular endpoint on my IoT agent. So it'd be the IoT agent / IoT / D, and I've got various attributes which I want to have on all my entities once they exist. So if I want to have a heart rate, it's going to come in called beats per minute, BPM, but I really want to give it the name heart rate, which is going to be in my at context as this bio ontology blah 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 thing. And I want to put in, this is the metadata, which is property of a property, which is it's written this way around because this is using, as I said, this is common for NGSI LD and NGSI V2. So this is written in V2. The provisioning is written in V2 format. So this is saying I've got heart rate, and the heart rate is in UNCFACT 5K format, which is beats per minute. Or if I want to have a status, it's just an S. Or I have a GPS, it's a some sort of location. Or I want to have various other things with my device. I can get some bits of static data. You can see here I've got attributes. These are the ones which are actively uploaded by the system. I could also set up what are called lazy attributes, which are things where I need to go off and request it later on, but we'll come on to that more later on. And this, did I send that? I did send that, didn't I? Yes, I think I'll just send it again. It probably won't let me do it twice. No, it did. That's fine. So it's created it. So I've done it twice. Okay. And then next thing I need to do is to provision the device itself. So for each device, again, I can add additional or overrides to existing static data. You can see this is an array of devices, but I've only got one of them in there. And again, what you have is whatever's the name of the device in the real world, whether that's coming from, in this case, it's part of the request, which you will see from HTTP. In the case of you're using MQTT, it would be on the path of the MQTT topic, which would be explaining what it is. If you have a LoRa network, it would be part of the payload. Same with Sigfox and so on and so forth. It would depend on which protocol you're actually using to get hold of this information. Second thing is saying, what are we calling it, the context broker? Because obviously a correctly formed entity will have an IRI for its ID, or in this case it's URN, and it's going to have, obviously it needs a type. Time zone is important because if you have any timing information in your system, and indeed I think I pushed observed that into the system, it needs to work out, well, is that offset by 1 hour because we're in Central Europe, or is it offset by -5 hours because we're somewhere in the Americas? Obviously, you want to make sure your data is relevant. And yeah, I can set up multiple things. I'm just going to set up one attribute at the moment. Once again, it's just giving me a creative response, not a problem. Now, for this particular payload, and the reason why I tend to use ultralight for the tutorials information is that it's readable, it's human readable near enough. You can see this is a payload of T/3, which means it's going to say, it's going to divide the attributes by bars, and you can say this is what I now. It is agreed between the device, which would be sending this, and the IoT agent, which is currently listening on that particular port 7896, that's the payload of the device. And if you look up here, I've got some sort of a magic key, and I've got some indicator I for the this is temperature 001. So if I just send that, and then if I just look at the service, you can see that was mapping back to my API key. So you can see that the data which is coming in aligns with something I've configured. So I've got an agreed key to make sure that we know what this device type is. What has happened is that there is upsert has occurred, and if I go to my context broker, I can just send the data through. I've already got this is key. No, I've got just with the attributes. I've just got the temperature attribute. You can see I've got a temperature of 3. It's type unit code. Observe that. If I remove the, you can see I'm looking at a specific service path to make sure that should be an NGSI LD tenant, but it's sending both. If I look at the parameters, if I didn't get rid of the attrs parameter, we'll see what else it's put in there. It's put in quite a lot of stuff which you might not have expected because of the way I provisioned the device. I said when I was doing creating the service, I said I have a location, I have a heart rate, I have all these static attributes. It's given me values for all those. If I go back to where was it gone? Dummy device measure, not that one. That one, sorry. So you can see I've actually got been sent all these values, but I've also been sent the static data, and even the static data in this case has got observed that pasted into it, because that's the way the IoT agent works, in that configuration either on a individual device level or on a group level at some point, it could update those values for you as well. Now, if I move back to the presentation, where's it gone? So as I said, I set up my my group. I would usually use property as my type, but you can also use JSON primitives or property relationship, or JSON primitives like integer, float, string, etc. It will read those in as you would expect them. So obviously a string is basically just a property, ordinary thing. If you want to put in complex data, at the moment that would come through as a JSON object with a special @ type. You can see here that the data has been set up as you would expect. Attributes, static attributes, and potentially lazy attributes coming off later. Now, I can, if I wish, within the way I define my devices, as well as setting up a static attribute, I can add in link metadata. The link metadata is saying for this particular device, which is device temperature 1001, it is placed in building 001, and it will add in a provided by relationship as well as the value. It'll also update building at the same time as it updates temperature. Why is that possible? Well, if you go back here, you can see the upsert is actually an array of entity updates. So it's perfectly possible to update both the device and the location the device is currently connected to. We can see some of that with more data later on. Now, GPS is a little bit more tricky because obviously you want to be able to set your location. Your location is obviously a geo property, and what goes into the context broker needs to be in the GeoJSON format. Fair enough, but what's coming into the IoT agent could be virtually anything, really, couldn't it? So the IoT agent is clever enough to accept multiple formats for the data coming in. You saw an example of an ultralight string payload when I had T/3. If you have T/long lat, long lat, that, and you've already set up the attribute as a geopoint, then that will be interpreted as being two separate values. It is possible to set up the values coming in separately, so you could have longitude of 13.5, latitude of 52.5. What would need to happen there is you'd need to configure the provisioning to be able to interpret the values. There is also a companion IoT agent. As I said, this is using ultralight format, using JSON format, which I'm sure you're all familiar with. So it would be perfectly possible to do the equivalence as a JSON object. If you can happen to put your JSON object as GeoJSON, well, you're laughing, because obviously that can be pushed straight into your context broker in that format. However, it's much more likely that your incoming value is going to be a bit simpler than that, because your device is stupid, and therefore it also accepts arrays or a string. It does its best guess to try and get this information into the system. When you are provisioning specifically a geolocation, you can use for IoT agent, you can use GeoJSON is the default. If you use GeoJSON, it will be a point. If you use geocolon something like geopoint, geopolygon, geo whatever, it will be one of those. Obviously, use the standard data. You can see at the bottom what I've got is what's known as an expression. There is a Jexel library within the IoT agent which can manipulate the data. So if you happen to have, I don't know, a Unix timestamp within your payload, and you want to get that out as a ISO 8601 date, which is obviously the format which context brokers need, you can do that switch within the data. What's happening here, and again, there are more examples in the actual documentation, is that it's looking for, going back to the previous page, along and lat, like the second example in the ultralight, in order to get hold of the data. It will only update location, however, if both long and lat are found in the request from the device. Now you could see from my device, I was doing a post request. I was doing a post request with a body. You could just, as I said, it could be whatever transport you're dealing with is how we're listening to the system, and they are converted as expected. Right, let's move on to actuations. This is going the other direction. Actuations are getting, as I said, are now better defined than they were when I first came up with this slide deck. So I'm going to also switch to a more modern example. But the way that an actuation works is basically the contract which a context broker is offering our system. If you do a patch onto your context broker to update something, and that particular attribute has been registered as being something else in the real world, like, for example, I'm a ring attribute and I'm a bell. Now, that will be, because it's registered, the request will be forwarded to the whatever's dealing with it, in this case, the IoT agent. IoT agent obviously is listening in a well-known location. And then what's more, it will retrieve the data, parse it. It will assume that the names of the attributes are the ones it expects, and I can explain why that's okay in a second. And it will then pass the information forward. The entity specification, it says there on that slide, is still being discussed. It was fixed in 161, which was published in September. So the default, if you do a registration, is federation, but the sort of registration that an IoT agent does is what's known as an exclusive registration. And therefore, it's saying I'm the one who is responsible for this particular attribute. We'll see an example in a second. It is also possible to do this using subscriptions, as I mentioned earlier. There is very early discussions on how you would do a full actuation service as an interface. It's not there yet, so I won't go into more detail, but what I can say is that this is fine for simple devices, simple actuators. For the 90% case, you'll find that actually your IoT devices are just giving measures anyway, so it's not difficult. And what's more, this is a code which is to be found within the IoT agent node lib itself, so that you know that when that is released with an update, it will work with whichever system you're talking about. Now, to provision a actually, I'm going to slightly change that. There we go. That one. That's what I wanted. Push that over there. Right. So you can see here, right. I have got here a device provisioning within the standard API of the IoT agent, and similar to measures, it's got an array of commands on and off. Right, fine, okay. But what we can add in here is that you must have somewhere it will push the data to an endpoint, and it's got obviously it's a device which is has a well-known IRI. What actually needs to be added in this system these days are a few additional bits of information. You can see, and I'll highlight them here. If you add in a context source info key into a registration, it's additional information used for that registration. And the key Json LD context will mean that the context broker itself does an expansion compaction operation before passing the data towards you, which means that the data you receive will use your preferred short names. Yes, it does look like a little bit redundant in saying we are using context XYZ, but it's also saying we're using context XYZ and context broker. It is your job to pass the data in this format. Now, because, as I said, federation is the default, you need to specify a mode. The mode is now exclusive mode. And you would also specify a series of operations. Update ops and retrieve ops. Retrieve ops is for lazy attributes, which is basically the same as a going to work the same way as an actuator, but with gets. Update ops is just saying I respond to various patch endpoints. So I'll just get rid of that for the second. You can see that what's happened is that the C-source registration has been set up with the various elements involved. Properties is now called property names, by the way. So what happens is that once you've done that, your context broker is set up so that when you make some sort of request, you'll notice that the request at the top, the one to the context broker, looks an awful lot like the request which is received forwarded to the next element on the line. The IoT agent is just a registrant. All registrants are designed to listen in on either all or a subset of the context broker endpoints. Obviously, this is a very limited registrant. It's just listening on patch. You could, of course, theoretically set up an IoT agent which could do merge patch these days, and that's also in progress. So it will pass the data on. Let's have a look at that one in action. So my provision and actuator, what I've got here is, as I said, I've got a couple of commands. I'm calling it on and off, and I've got some static attributes. You can see I'm doing something in the barn again, and I've got the transport, some data about the system transport X. So I send that. I can now invoke a command. Before I do, I'm going to go back to my farm. Let's have a look at my farm. Nope, wrong one. Devices. Got a series of devices here. Move that across slightly. So if I send that, oops, not quite right. We should get a value coming through the system. Is it failed? It's failed on the. Okay, no content. It's failed. So usually when I'm doing that, I should actually get some sound coming through. But for whatever reason, it's failed. So you'll have to trust me on that. I've got other videos which show the thing actually running in action. So first failed live demo. There will be others. Right. So where were we? This one here. Okay. If you wish to combine NGSI V2 and LD, there are two ways you can do this. You can either have some system which is listening on a subscription, and then when it retrieves the data, it pushes to another context broker. Or you could have a proxy, a wrapper around a V2 context broker saying this is the LD endpoints. You can see here what I've got. All I've done here is that I've got a registration in sorry, a subscription in NGSI V2 format, which is saying duplicate each of these devices, and then whenever something comes through, I'm going to update the value in question. Right. So, whilst I'm working out what was wrong with that one, I'll see what else we've got. Okay, so that is the end of the first section I will deal with here. I'm now going to have a quick look in the chat and see what we've got there as far as questions are concerned. So that's here. Oops, minimize that. So, any questions? Okay, right. I can see in the chat there's various things about trying to run the tutorials on Windows. The tutorials are written to try and be for as broad an audience as possible, but I haven't got sufficient bandwidth or time to get it necessarily working on literally every system. So going for the lowest common denominator, they are Linux based. Indeed, you will find, I can't remember if I've done the LD tutorials, I've certainly done for one of them with the LD or V2. You can start running some of the tutorials using Gitpod, which means that you can just spin up a virtual device, and you can run your curl statements directly. If you are getting errors on the services string, which is the usual entry point to this, then suggestion is that you should try and use Cygwin to try and emulate a Linux system. Second question, I've just joined the training camp, and I was wondering how long the replays will be available. What will happen is that we will post videos or edited versions of the videos. Obviously, you don't want to hear me umming and ahhing and getting things wrong, onto the FIWARE YouTube channel. It's either the FIWARE YouTube channel, the i4 Trust one, but it's probably going to be the FIWARE one. If you check the FIWARE LinkedIn social media, it'll give you more information as to where things actually are. Now, this is where we're going back to the same thing here. You've got the line feed versus character return line feeds, because this is really very much this is really very much a case of I can't deal with Windows and do my day job at the same time. So apologies to Ian, we're not going to be in a situation to do that much on Windows, but there are various workarounds. They are common workarounds which you can find on the internet rather than necessarily FIWARE specific. I'll just very briefly show you something on the tutorial, see if it will work. Where are we? Wrong one. That's what we're after. I think it's the V2 ones. I don't know if I've done all of them. The tutorials can be found on GitHub, of course, GitHub FIWARE. I think it's V2 I've done rather than LD, so unfortunately the wrong ones for this particular training. But I will be passing this on in a second. Once I've got time, I think. So working with linked data is a good one. Yeah, you see there's a button here and this is actually showing how to use NGSI LD for V2 users, called Opening Gitpod, and that will allow you to run the system remotely, and it will start up your broker to do stuff remotely, so you can just assume you're using a Linux system. Indeed, I have an issue myself when I'm doing the next section. In that, because I'm running on a Mac Silicon, there's a component I want to use which doesn't currently or didn't have a compliant Docker image. So I can do that remotely. So you need to be a little bit careful when you're using Dockerization. So I will try and get the Git pod buttons up and running as soon as I can to give a wider range of people things to do. Right, so if there's no further questions on that, I've been talking for approximately an hour. I'll go off and get a quick cup of tea, and we can come back in about 5 minutes. So let's have a short pause at this point. Right, welcome back, everybody. I'll grab my quick cup of tea. I'm losing my voice a little bit, so I will shut up a little bit later on. We're now going to start covering a few more parts of the Fireware Catalog. If you have a look at the Fireware Catalog, Fireware on GitHub, you'll see, obviously, the standard simplified architecture diagram. We've just been dealing with the connection to IoT, connection to robots. I won't deal with media streams, haven't got time. But you can see that the way that they tend to connect to your system is via registrations. If you move up to the section on the processing, and indeed other components which are also within the core content management system, they tend are much more likely to be based around subscriptions. Every single component which somehow works with Fireware is either going to be reliant on subscriptions, registrations, or that upsert, usually the HTTP endpoints, usually that are upsert. Although, for example, there is in the data publication, there's an extension to CCAN, for example, which actually converts your get HTTP get entity format to a system which will work. Now you'll see here that this should be your first stop when you're trying to work out where are you going with Fireware, because there are examples of what you might want to use, where you might want to use it, and what components that there are. And we know that these particular components are being updated on a regular basis. These people turn up to the Fireware Technical Steering Committee. They're interested in working out where we're going. They're influencing where we're going and doing the various parts which are within the system. I look within core context management. You'll see there are a wide variety of components. Each one of these is this looks like a massive repository. It isn't. They're all outlinks going elsewhere. But you can see here things like Canis Major, which is the persistence to blockchain component. It used to work on subscriptions. It's now works for a slightly different mechanism. Cygnus and Draco are two mechanisms of trying to persist data into other systems. I've got a little video later on to save my voice, which will explain how Draco works. Then you've got things like your various context brokers. There's a connector for PySpark. If you're a system doing machine learning, you're a Pythonist, then you would probably want to have something using Python or PySpark. Similarly, we've got Quantum Leap, which is a persistence to a time series data. Again, I'll show a little video later on explaining how it is. And then beyond this, there's applications of which context broker you should use. This is why you should use Scorpio. This is what Scorpio reckons it's good at. However, if you want to go for Orion LD, this is how it justifies itself. Go over here to work out what you want or what you want to try. All this is open source software, so it's free to use. You can work out where we're going, and so on and so forth. If you find that the component of your dreams is not present in the Fireware Catalog, don't panic, because all that there are special restrictions for elements which are in the Fireware Catalog. As I said, these people have to turn up to regular technical steering committee meetings. They have to be commit to a certain rule book of what you do to become a Fireware component. This is where the roadmaps should be. Someone pointed out the roadmap for Canis Major was missing, and yes, it is currently missing. It should be here, but that needs to be chased up. But if in this case, there's also another list, and this is the so-called Fireware Awesome list, where there are additional third-party components which I have typically I have very little experience of, but control. These are people who are offering their Fireware components for free, and if you say again, there's some more stuff with Python. There's some more stuff with simulating devices, probably better than my farm or whatever. And also at the bottom, you'll notice there are a couple of plugins for Grafana. There are actually some more than this. These are just the ones which we've got hold of the data for. On top of that, you've got things like Fireware Node-RED, for example. So Node-RED is a streaming service, and if you go over to Node-RED, you'll find that there is a series of connectors which will be usable to push your data into a system. If you're using Apache NiFi, then you can use Draco. Draco is just a few additional components added to Apache NiFi. This is just adding a few things into Node-RED. There's also the ability to do stuff using Apache Flume, which is Cygnus, and also show some examples of that as well. So you've got a wide variety of software you can look at and try out before you need to start rolling your own. Now, for this particular, I'm not going to go through the entirety of this slide deck because it is somewhat outdated, but the principles work the same. It's actually a V2 slide deck, but I will explain what I mean. The principles are the same for LD and for V2 because all these components are based on subscriptions. Right, so we've done that one there. Okay, so if we are to take the world's simplest component, a data persistence hello world, I can write my own stuff. Frankly, I can just say, okay, I am going to have a component which is capable of listening to a subscription. You have already seen from the first 3-hour session I ran a few days ago, a subscription has got the payload of a subscription has got a well-defined payload. So you know that it's going to have, I think it's a data attribute, which has got an array of entities in it with various attributes. From there, I'm saying I've got I know what the format of the data is. I'll write my own. Let's write this to a database component. Job done. I've got what I need in the system. The reverse of this is also true, in that there is actually this component called Fireware Apollo, which again listens to a subscription. Listens to a subscription, looks at the payload of that, and then pushes that data back into a context broker. So all that you've got to think is that when you are trying to connect to third-party systems, It's a subscription. Get my data, do something with it, and then push to a further system. This is an example of a V2 V2 subscription. Same thing happens with LD. I just create a subscription. I narrow it down to a certain set of IDs or a certain set of types, and then I can decide whether I want to get, for LD, it's going to be key values, concise or normalized, or potentially, if you're using Orion LD, you've got a couple of custom formats, which are actually saying, I want it in V2 format, because there are already plenty of components out there which are expecting V2, which may prefer that to LD format, or it used to be the case whilst there was a transition for both interfaces. The problem with this is that although it's very simple, is that there's no backing for it. So you'd be better off, if you can, using one of the existing data persistence components. And I will give an example of Draco in use as a short video presentation in a second, because obviously my little point solution, and I think I've probably still got the code here somewhere. I'll just see if I can dig it out for a second. Is it gone? There we go. So if I look in here, I think it's this one here, context provider. I think it's in V2. Buildings update. Okay, so all I'm doing is I'm listening here with a request, and you can see whenever my subscription fires, I'm going through for the data element of the body, and I'm saying I want to upsert my values to a database. This one happens to be MongoDB, and you can see here each element of the payload has got a building ID, a building name, a building address, and I push the data in. I don't care about my errors. This is throwaway code. We can do whatever we like. I may well have the LD equivalent elsewhere. It'll be the same bit of code. So for what, 10 lines of code? I mean, obviously there is a route which is listening into that, which I think is on index. Here we go, subscription. Is it? I'd have to look to find out what the which particular route that is. It's somewhere else in the system. What there is it? But that's just, you know, here's a very simple throwaway express application to deal with it. The advantage of using one of the existing components is that there is a community behind it. Typically, you'll find this code is on some companies or universities' website. So if you're interested in Apache Flume, you go over to Telefonica's GitHub repository, and you can get all the data there. Obviously, they have a reputation to try and upkeep, so they're not going to give you software which is non-conformant. They will reply to issues. They will update the endpoints as necessary. If you're looking for Apache NiFi, then you go over to the University Polytechnic of Madrid website, and there's a community behind that which will help with the connector for NiFi. In all cases, we're just talking about a simple Dockerization of the system. Now that's okay. That's better. So what's the difference between Flume and NiFi? Well, they do the same job. They are both Apache components, so they are using the Apache license. They are free open source software. We're not trying to build everything from scratch. We're leveraging on existing open source initiatives out there to use the code the way it's supposed to be. The main difference between Cygnus, which is Apache Flume, and Draco, which is Apache NiFi, is actually which syncs are available. There's a slightly longer list, I think, for Cygnus because it's an older system. So, for example, there is a Cygnus sync to DynamoDB, which is the AWS database. I don't think there's one for Draco yet. It may want to be updated. You can see you can push to things like HDFS, which is a big data system. If you've got that amount of system, you can push to Kafka. You can push to some standard databases like MongoDB, MySQL, and CartoDB. I think if you look at the next slide. Yeah, so I'm going to do that one. I'm going NiFi. You can see there we go. I'm not going through all this. The list there is longer than the list was for NiFi. NiFi's had a shorter list at that point. But let's see that one in action. And I know this particular bit will work because it's a pre-recorded video. So let's see what we can do here. That's Flume, isn't it? That's right. I don't want to get it.
Component within the Fireware Catalog. There is an alternative which is called Draco, which is based on Apache NiFi, and this is where I need to get this started because it takes a little bit of time to get started. So
setup takes about 5 minutes, so this is the edited video.
It takes some time to bring the components up, bring the components down. As I said, this is where I would usually take a break. Stopping that one. So I'll try and talk over this whilst the thing loads. It can take up to 90 seconds or so because of...
I'll just skip that bit if I can. And my video's now paused. We're having recording problems.
It's a set of available syncs at the moment. The documentation for both of these components can be found, as you'd expect, on the internet. This would be the Cygnus thing in Fireware Cygnus read the docs, and as you'd expect, Fireware Draco read the docs is where you're going to find the Draco information. Now, once again, I've started this up again, so I should go back here and see if we're running yet. You can see I'm waiting for Draco to start up. Draco, I'm pinging I think it's every 5 seconds.
I'll just change the quality because I'm going to see some stuff on screen in a second. Just wait for it to buffer a little bit.
See if there is a response. At the moment, it's still getting ready. It would take a bit of time, although my tutorial is already available. I go to the...
It's buffering again. Great. We had the same issue the other day, didn't we?
There we go. Draco itself, you can see from the configuration file, has not actually got many Docker endpoints, environment variables. You can see it's just the port it's listening on. It's listening on 5050, and it is configured on 9090. All of this configuration is currently found within the graphical interface itself, and that is at the moment it is not persisted. So if you want to persist it, you're going to have to save the running Docker image. There is work ongoing to attach various volumes to this so that the elements you require are available and persistable for, obviously, for disaster recovery reasons.
That has been done now.
Let's see. Oh, not be there yet. Let's try again. So, as you can see, once Draker gets going, which can take over a minute, it is a graphical user interface, and you can use templating to decide what you're going to put in. Now, the one which we can look at is called MongoDB tutorial ad. I can group them if necessary. And you can see at the moment there's nothing coming in, absolutely nothing coming in, because I haven't set up a subscription. It's just listening on a specified port. If you view the configuration, you can see things like where is this persisting to? This was a configuration point for environment variable from Cygnus. What version of NGSI is it dealing with? Is it dealing with NGSI v2, v1, LD, whatever? And how is it actually going to be passed in the database? And once again, it's going to go to a database called STH. Okay, so now that we know that it's there, we can just check the health. And you can see its system diagnostics is running. It is quite memory heavy compared to Cygnus, but obviously there are advantages and disadvantages of both. And if I now do this notification, as you'd expect, nothing very much will happen until I've started my devices. So let's make sure my device is running. Yeah, my bell's running, so let's unlock my lamp on. And if we go back to here and refresh, you can see there's a lot more elements which have got all the motion sensors, all the bells have got data going into the system. So that was Apache NiFi after the break.
As you can see, it's a lot easier to run that demo as a recording. There's no real need to change it for LD. The only difference would be, of course, that instead of having V2 as the expected payload format, it's LD, and the subscription is to the same endpoint, but it'll be in LD format. One additional thing which NiFi can do, of course, is that NiFi does offer you the ability to do things like set up a cron job to, say, read a CSV file. You know, just pick something off a drive somewhere. It also offers you the option to fire an HTTP request. It also offers you the option to format some incoming data as JSON, or you could manipulate the data using a kind of JavaScript syntax. As such, that means it also could be used as an input mechanism. There is yet another video we've got on how to create your customized systems, but where you, in all cases, at some point, you're going to have some sort of custom code. If you want to have you could have a custom IoT agent, for example, which is reading a CSV file. Fine, not a problem. You send a CSV file to an endpoint. It will do the necessary chopping up of the data and then pushing the data into a context broker. You could just as easily have that if you wish to. Just as easily have that if you wish to do this using tools such as NiFi. It's up to you to decide where or which system, at the end of the day, you'll be maintaining. The NiFi system that was demonstrated in Gran Canaria at the FIWARE Summit in September was reading river levels, I think, 3 or 4 times a day. It wasn't particularly a heavy load, but it was retrieving context data from what is effectively a very much a legacy system. You know, someone was typing stuff into an Excel spreadsheet once a day to take their take their readings. It was useful when you're making further calculations, but it wasn't something which would deal with the remaining issues. You saw there I was pushing stuff to a MongoDB database. It's a subscription. I work out which attributes I want to put. I put the data coming out further. Now, when you are dealing with a HTTP protocol, you don't have quality of service and no guarantees that all messages go through. Yes, that is perfectly true. Hillary knows his stuff. One of the ways to attempt to mitigate that is that there is a mode within FIWARE Quantum Leap, which again I'll show an example of that a little bit later on, which effectively will try and queue the data. So if, for example, you get an overload of the system, it will take some time to deal with all the elements one after another. Indeed, if you're looking at NiFi, if you look at the way the data is flowing, you can get a backup of data, perfectly possible. If there is a backup of data which, frankly, is never going to get cleared, yes, you will start losing some data. The question there is, are you now really dealing with context data? Could you throttle your inputs somehow? Usually, what we want is the state of the current system, and if it's sufficient to get a sampling of where the data was, you're not going to necessarily have literally all the points of the graph available, but that's better than having none of the points of the graph available. Looking at Smiris' question, would this work the same way if we had a CRUD API instead of a database like MongoDB? I think that's probably worthwhile having a look at another little bit of code just to explain that. Basically, yes. If I don't know where I've put that. Okay, where are we? It's in temp, isn't it? Right, this, I think you can see on screen now, is that right? Can you see my stuff on screen? I've got too many things on screen. Oops, that's not what I want. So that can go, no, I want the other one. Can you see my screen at the moment? Yes, you can. Right, fine. Okay, so once again, this is a little mechanism I've got where I'm doing a CRUD. I'm actually not doing a CRUD because that's more advanced. I'm doing the read. But what I have here is again another simple Express app, which is I'll get another bit of code. Proxying a NGSI LD request. NGSI LD comes in. It could be application LD plus JSON. It could be various other. It could have things like sysatters or concise or key values or whatever in there. But what it does is using GOT, it does a further request going on to the next element in the line. Now, the next element of the line, in my particular case, is an NGSI v2 context broker. So I'm doing a get and it will retrieve the value in LD format. And you can see here that all I'm doing at the end of the day, and this is actually something which the IT agents also do, for various different types of attribute, like the native JSON types or whatever, I'm making sure that my values are formatted properly. Date time's a good example. That I need to make sure that my dates are put forward as ISO XML date, so it's to ISO string, and so on and so forth. And I need to make sure I get my GeoJSON coming through properly in a proper format. Now that means that, again, I've got this little proxy around. It's pretending to be an NGSI LD broker, but it isn't. It's just responding to an NGSI LD endpoint, and the output is NGSI LD. That is obviously going to be something which is going to be behind a registration, and the registration will deal with it. Just very briefly, not answering Andrew's question, but I'll deal with it later. Can I document this process? Not live right now, but I'll have a look at it towards the end of the session if we've got time. Okay. Otherwise, we can just talk directly later on, because obviously I'm trying to cover a lot of ground in a short period of time. So yeah, this isn't difficult. This is just saying use the existing tools, create a subscription the way a subscription is going to work. You remember how you saw the payload of the subscription, and let these tools do what they're supposed to do. You can configure things like Apache Flume, Apache NiFi, Node-RED, whatever, to chop out bits of data you don't want, modify it, push it elsewhere. That's where you can do the manipulation if necessary, and you'll end up with stuff in the database. Now, I think for both of these systems, you can set the configuration up as to whether you want to have a record for each attribute change, or you want to have a record for each entity change or whatever. Once again, you're going to have to look in the actual documentation to find the full power of the system. The important thing to know is that these systems exist. They are properly documented. So yeah, the one line here I'm saying here, which is the really important one, is, and I hope you've got this here before I close this particular slide deck, is that context brokers are not databases. Databases are databases. Context brokers are there as an interoperability layer. So don't do your full or assume you're going to have full context broker stuff coming out directly. If you want to, or if you find that you're trying to do something stupid in a context broker and it's not working, like, I don't know, you're trying to do natural language queries, you probably need a database. There's no problem in copying your data elsewhere if absolutely necessary. Do what's necessary. Do what's necessary for you. I think that is that particular section done, but we have more. So if you just bear with me just very briefly, I'll try and get the next slide deck up and running. Oops. I'll just... Actually, no, I'll do it another way. Right. What I'm going to show next is an example of another bit of data persistence. This is using NGSI LD, and we're going to start showing something which involves eventually getting to towards a graphical interface. This is how we're going to move from using a subscription Quantum Leap to CrateDB to Grafana. So let's see how this bit works.
Into a system, which means that in this particular case, we're going to have an NGSI LD context data coming out from our devices. As it happens, our devices are going to be on a smart farm. They will go into an IoT agent, which will obviously push out data into NGSI LD, into an NGSI LD context broker. So this means that we have a common interface. We have the context broker NGSI LD interface for all the information we are gathering. The stuff at the bottom of the stack isn't particularly relevant to what we're doing here. We'll need to raise an NGSI LD subscription, which means that we have a well-known format for how the data is coming out when the data comes through. And this will be able to persist data to time series data. It would be possible, if we wished, to raise the NGSI LD subscription to a proxy, which means we would have an opportunity to manipulate the data before we proxy it on to Quantum Leap. We might need to do that in an NGSI LD scenario if we wanted to do an expansion compaction operation, changing the values of the attributes before it reaches Quantum Leap. Now, Quantum Leap in this case is our data persistence mechanism. It is a separate component which is there purely for pushing data from one place to another. It is important that you must separate your concerns into multiple microservices. At this point, Quantum Leap is pushing to CrateDB. CrateDB, the latest version, again, is Apache 2. So again, you've got no issues on your open source database, and it is usable as a data source for Grafana. So you can see we're splitting up the various different elements into different components so that we can follow a chain of persistence. And finally, we'll get round to displaying the item on screen. Let's have a look at this in action. So I have a little little tutorial which is running the various elements of my system. If we have a look at the Docker Compose, you'll notice that we have got, where's this thing? It's down. Grafana. We've got, when we are loading up Grafana as an other service, we have additional plugins which we are loading. We're loading in the Grafana map plugin, the clock plugin, the world map. This will become important when we go through later on in the system. Now, within Quantum Leap, it is saying I will be persisting out into CrateDB. So it's important. So you can see how the data will flow from A to B to C, and Quantum Leap is going to be our think in this case. Okay, so we've now got the smart farm up and running, and we've got some data coming in from our devices. There's no real need to know what the devices are. This is using ultralight, but it doesn't really matter. You've just got data flowing in to your context broker. You can see I've got pigs and cows moving around on screen, and I want to be able to track these in real time. We need to check to see that we've got the thing up and running now. In order to get data into Quantum Leap, you need to create a subscription. This is an NGSI LD subscription here, and we'll start off by showing uploading the filling stock. Now, it's possible to have a more generic subscription. This is just putting the stuff normalized NGSI LD format, and of course you have your app context in there as well. This is just going to update the filling sensor. Let's see what happens. It's created a subscription, and again, let's do this the same thing for our animal location. The animals have got type of device, and you can see that we are watching location, status, and heart rate. When I provisioned the devices, the filling station had a static attribute, which also would have a location. When you're typically with a system based on FIWARE, you're talking about assets in the real world. It's therefore necessary to be able to locate these items in the real world, or potentially have something like a controlling asset, which is saying, I am actually within building 1 or whatever. Now, this means that when you have stuff, you will be able to display a map with the locations on it. For the actual animal collars, it's a little bit different in that there is a device, try and find it, there's a temperature sensor, here we go, device. There is a device service, and the service itself is passing in GPS location as a location. So it means that within the context broker, you've got a location. This should be persisted and read by our subscription passed on to Quantum Leap. As we can see, the filling sensor has been notifying. It's been sent so many. This has been sent 9 times, and the other one has been sent so many times, and so on. If you have a large number of varying data, you'll need to throttle the values which are received. So this is going into Quantum Leap. Quantum Leap itself. See if you can see the logs. I've got the logs running. It's taking a bit of time to come up. There we go. Quantum Leap. Quantum Leap itself is receiving. You can see it's receiving the data now. There's a reason why when you set up Quantum Leap, you might want to have a Redis database that's front end, in that you don't want to overload your services. So at the moment, we're reading in several positions of cows or pigs, but you can also make to ask for time series information. If that information has already recently been received, it may go for the database. So we can see what has actually been happening with our system by, say, retrieving the last the first 3 samples from our filling sensor. Let's see, is it actually sending me data for the filling sensor? It's thinking about it. So that doesn't appear to be oh yeah, we get no records found for the filling sensor because the filling sensor has not been. But what about if we were to look for cow 1 instead? And it's going to think about what's going on, and eventually it will get hold of some data. I've not found for cow either because I put the name wrong, I think. So you can also go direct to the crate DB itself to do queries. This is effectively what the Grafana database will actually do. It's actually going to retrieve information direct from a table which is going to be based on the NGSI LD tenant or the Fireware service name. It's called Open IoT, and this one MT is just a prefix, and it will receive data for a specific type. Going on to Grafana. Grafana, first thing you'd need to do is to configure your data source. Now, the data source in question is not, it's a CrateDB data source, is not one of the standard ones you've got. However, it is the equivalent of a Postgres. So I need to get my values in there. So just a minute.
Turn that down slightly. We'll just change the speed because it's getting a bit blocky. He says it's now just failing completely. One of the reasons why I failed to get the data from the filling station. I'll just pause that actually. One of the reasons I failed to get the filling station on that particular demo, and I've no idea what's happening there, is that there was a typo in my subscription, and actually I was getting hold of I was attempting to get hold of filling level or filling level station or something like that when it should have been filling level sensor. So yeah, I've now completely broken this, which is not good. I'll just have to break that. So I think probably the thing to do, because I'd like to show you the actual video of this, is again take a short break whilst I leave this to buffer, and I'll continue the explanation in about 5 minutes. So I'm going to get another cup of tea because my mouth is very dry. So I'll see you folks in approximately 5 minutes. Right, we should be buffering now, so I'll continue the session.
First thing you'd need to do is to configure your data source. Now, the data source in question is not, it's a CrateDB data source, is not one of the standard ones you've got. However, it is the equivalent of a Postgres. I need to get my values in there, so just a minute. It's listening on the I'll call it Crate. It's listening on the standard CrateDB host port. It's going to be called CrateDB because I'm running this within its own network. My database is OpenMIT. I have a user called Crate, and I have no password. Stable. So you can then test to see, can I actually connect to the data source? And yes, the data connection is okay. At this point, because we've actually got the data in our dashboard, we can choose a visualization. You have a range of visualizations available here. Obvious one is to go for a graph, and the graph will give you a little wiggly line. At this point, you would need to connect your your table to work out where we're coming from. Now, the time column which Quantum Leap saves is called time index. At the moment, for the NGSI LD data, it's actually taking the data subscription, but it should take the observed that. And then finally, if we go for an entity ID, column unknown, value is unknown. Now that's because it's not value. As I said earlier, you can transform from you can transform your data if you need to in a proxy before you receive the subscription. It's called heart rate, isn't it? And we can actually give it an alias as well. I can give it an alias of value. And eventually, as you can see on the side of the screen, our cows and our pigs are now showing heart rate for the last 5 minutes. You can see that there's various spikes, and you can also see that the typical cows have got a lower heart rate than the pigs. The pigs have got just over 1 beat a second. Now, it is various visualizations are possible. If instead of getting a changing value on a screen, you can also format this as table data, which would then be displayable under a different sort of visualization. Let's add a couple of extra columns. Now, the location is standard naming for NGSI LD. It is preferred naming for NGSI V2. But the value which this particular plugin I'm doing wants to call it Geojson. And we also want to have various types. Now, entity type is what is called in the database by Quantum Leap, but it is actually the type attribute. And you can see nothing is happening here until I move on to the visualization, where instead of going for a graph visualization, I can actually go for a map panel. You can then see that my devices are being displayed as a map layer because I've got a different value. And indeed, if I move the screen up properly and display my screen, I can actually see that my values are coming into the system. Let's zoom in there rather than change the defaults. You can see that my cows are based in Berlin. Oh, apart from one of them, which has been escaping. Now, this is the sort of information you couldn't easily get from the screen here, because you can't tell that one of these pigs or cows is actually in a completely different location to all the others. You need to choose the appropriate visualization to work out what's going on. You can, of course, also do things like thresholding. You could see what the values of the various heart rates are on the screen, or you could even add in colors. Sorry about that.
Right. Let's leave on that one there. I'll go back to my presentations. What's the next bit to look at? Stop presenting for a second and get the camera back on. The idea here, as you can probably see, is that for all these FIWARE components, we are leveraging other open source systems. We're not doing end-to-end. There's no such thing as the FIWARE graphical interface. You can use something like Grafana. You can use components directly within the Fireware Catalog, such as Quantum Leap, not Quantum Leap, such as Wirecloud. But you, at the end of the day, what you've done is that you've taken your data from that context broker, from that context layer, and you've got it into whatever system works for you. For this particular case, we put it into a time series database. The data is then using standard tools to come out. There is, if you go back to looking at the Fireware Awesome list, I believe there's a connector which will directly retrieve entities from a context broker and display it using Grafana. What Grafana's doing is it's basically a sync for data formats. In this the example which is shown in the video, it was just reading from a database, but there are multiple ways you can do it. You can even get a trace from the system saying, yes, okay, I want to get the data from over a period of time and show that. There's I don't know if there's an NGSI LD version of that. There's definitely a V2 version of the time series, so you could get a trail over time. So this is an overview of the various elements which are available, or a selection of the elements which are available. I'm going to keep this presentation shorter because the idea here is that I'm going to open the floor to further questions, and we'll try and get some specific details. So let's quickly look back at the questions list. The first one is from Andre again about a specific QA listing, which I will just bring up on screen as well. I'll have to share, display the screen again, present to audience, share screen 2. There are various things which the Fireware Foundation does, and one of the things which we have been doing is a certain element of Q&A across the catalogue. As I said, the catalogue is all third-party components who follow various rules. Now, what this document here is, and it appears to be a rather out-of-date version of it as well, is one of the QA activities which was labouring the status of the various different components. Now, if I remember quickly, so that's 2018. So that's probably 3 months after I joined, or something like that, was when it was last updated. So that particular version I would not have had anything to do with, but I can try and investigate what the current status of the Q&A labeling is. It's likely that things have changed over time. There are various components which are, say, no longer in the Fireware Catalog, such as Eon. There are others which have moved from Fireware to being more commercial. There are others which are completely missing from the system. So that would have been a status of the system when it was tested for that particular run, and that would have been stuff which we would have been passing on to the owners of the system, and obviously they're passing on to the public, because obviously we want to make sure that we can explain what's going on. If you are, I'll stop sharing that thing. If you are interested in the Q&A activities, I don't deal with that myself directly, but I could try and put you in contact with parts of the core team who have got more to do with the Q&A activities, which, as I said, will change over time. So, for example, there's been a push on trying to improve the security of the various Dockerizations. And if you go over to I'm not sure whether you pronounce it Key.io or Quay.io, depending on how we ordered it. It's the Red Hat version of Docker. There are several Fireware images over there, which is which will explain, okay, this is where we currently believe the current vulnerabilities are. It is possible for some of the elements of the Fireware Catalog to build on the base image of your preferred choice, which means that if, for example, I don't know, UPM are a bit slow at updating one of their Docker images, you can build your own later version on maybe one with a security free. Obviously, these things are updated on a regular basis, but your level of security may require that you want to take more control of it yourself. Is there any newer version of those documents? I don't know is the simple answer, because it's not actually my area. But what I can do is I will attempt to find out, or at least put you in contact with someone who will say what the status of the Q&A activities is 2022 rather than 4.5 years ago, because obviously things have changed regarding production ready status. I think, like any open source software, the final decision lies with the user. Whether it's up to you to decide, does this component fulfill my needs? If the only requirement for a powered by Fireware solution is that you must have a context broker. So you are free to pick or choose or ignore a large variety of these components, because they're either not relevant for you, or if they don't fulfill your needs, go for something else. I showed you a video using Grafana. If Grafana doesn't work for you, you don't like Grafana, there are other graphical tools out there. It's not saying this is the one way of doing it. It's saying we are providing building blocks which you are free to use to build up your own system. So hopefully that will briefly have answered your question. If you want more details, Andre, as I said, I'll try and get the someone with more knowledge on that area. But that's my understanding of that document. So we've got another 40 minutes if necessary. As I said, we overran for the last 3 sessions, so it gives me an opportunity to at least get some of my voice back. Any further questions from the audience? Okay, Kevin, is InfluxDB in your plans to work with? I won't answer that question. I will tell you how to get the answer of that question. Right. Let's say you've got an interest in, I don't know, either using Draco or using Cygnus. And let's say neither of them at the moment are using InfluxDB. The thing to do is to raise an issue on the GitHub, as you would do for any other open source system. Ask a polite query to say, is this likely to be happening in the near future? That assumes, of course, that you haven't actually that you've actually already read their roadmap, which should be part of their GitHub repository. It's usually in the root. It's either in the root or docs. I can't remember. Called roadmap.md. Which says, okay, maybe we say we're doing Influx in 6 months' time. If you approach an open source community and potentially say, there's business use for this, they may increase the priority of that system. So they may give you what you want quicker. Alternatively, you've got to remember, this is open source. There's nothing stopping you contributing the InfluxDB connector and letting, I don't know, Telefonica, let's say, do the QA on that to say, yes, it looks like this is working for us. Because obviously, the way that we are trying to architect these systems is to offer a choice of endpoints you can use. And it should be the case that eventually it will cover what you want. Or if, let's say, there is a community who don't want to do that for whatever reason, you can get a direct no, which is possible. And even if you do get a direct no, and you want to proceed with your version anyway, there is nothing stopping you forking the code base and putting your customizations there. Now, obviously, that's not what we want. We don't want a social fork of GitHub repositories. But if that's really the only way to do it, it's the only way to do it. You will find, however, and this is saying probably an anti-pattern, but going even more to an anti-pattern. When you look at the various open source components, there are obviously licenses connected to each repository, and of course your fork or whatever must also apply to the existing license. So going back to say Cygnus, which is created by Telefonica, they are running it under an APL3 license, which is strong copy left. So they really want to have contributions placed back into open source. So if you have a new connector, what you can't do is to say, okay, I've now got this new connector and I'm going to start charging it, and you can't see my code. So be careful if you do want to start modifying, and realize that just because code is open source, it doesn't necessarily mean it's free for you to do whatever you want. There are certain obligations. Another example I usually give is if you wish to use the Scorpio broker from NEC, they are offering that context broker under the BSD Clause 4 license. And what that means is that you can't use the NEC name in the advertising of your product. So you can see there are certain things you can and can't do. Next question, which is Andre again. Is Fireware Lab still working, and can you comment on those activity? I think, Andre, you really need to talk to my colleague Fernando, because both of your questions have been directed not in my area of expertise. As far as I know, yes, Fireware Lab is still available. There are nodes available, and you can sign up for it. It is not something I use. Fireware Lab is effectively free rack space, which you can use, or free virtual rack space, a cloud environment, which you can use to create a demonstration. You can play with stuff. Now, again, I haven't off the top of my head got the rules of how to join and what's going on. But you should realise that this is designed to be a test system. It's not designed to be have high availability. It's designed to have a really low price. So it just doesn't cost you anything. So in that particular case, if you are interested, there is a link on fireware.org, which will say how to fill it in and go forward. But equally, if you ping me on LinkedIn, I will get you in contact with the people who are more closely connected to Fireware Lab. If I remember rightly, and this could be wrong, if I remember rightly, it's not the Fireware Foundation that owns these nodes. It's the providers of the nodes who own the nodes. So we're even one remove further away from working whether things are up or down. But as I said, this sort of infrastructure area isn't really my area of expertise, so I won't go to more details. Any further questions? May I ask you for some sort of attendance certificate? For me, no, but because I wouldn't usually deal with that. I mean, obviously I can send stuff through, but again, Alfredo, the thing to do is to send me an email, jason.fox@fireware.org, and I will endeavour to find the right person to actually provide you the right thing. Are you talking about here? I can see your title is PhD Student, University of N. I'm not quite sure what N actually is. We do have a university outreach program, and I would obviously pass on your request to whoever is. Just a minute, Charlotte's saying something here. Oh, we have done that in the past, is saying Charlotte, so she knows more than I do. So the answer is probably yes. But we will. I'll make sure you get the right person to send you the stuff forward. So it's not just some random developer Jason Fox off the internet. It's actually properly from the relevant people in the Fireware Foundation. As I said, the University of Naples. Okay, fine. You just cut off on the letter N, so I couldn't get the rest of it. So yes, we do that sort of thing. Okay, so anyone else for further questions? If not, I'm going to have to start asking you questions. Here we go. Okay, this is an interesting question because, I mean, the great thing about this session here is that it starts applying your data into the real world, right? So what Nikos has actually got some proper Json LD data stored in a database. Does it make sense to make this data available through a context broker? Yes. Wherever your system is, you will have, I'm assuming that you're not a greenfield operation, you will have data. You will have a certain subset of that data, which you want to start sharing between participants. If we're talking about data spaces, that's what we're talking about. Now, you'd have to think, okay, if I've got JSON LD data, that could be it's a lump of JSON with attributes, provided I can give it a type and an ID, which, as I said, is JSON LD compliant. All the other attributes could actually be an object within the values of that data. So again, I'd have to have a look at the structure to work it out. But it looks like you've got a set of attributes which might have a lot more structure to it than I've got beforehand. Right. So let's say we want to push some of that data towards a data space. What we can do then is you would need to have a trigger on your database, or your a cron job on your NiFi or whatever it is. You don't need some sort of process to start sucking the data out. And once a day or once a second, or when the trigger goes off, you'd need to do this update to a context broker. Only update the values which are necessary or you want to share. I mean, for the first open call of the I4 Trust, there were several experiments. I think that about 5% of the data was what they wanted to share. Most of it they wanted to keep within their own working system. It wasn't relevant to the project. You work out what you want to share. You put that into your context broker and push it forward. If you've already got structured JSON LD data, you've almost certainly got proper attribute names, proper data models, and a JSON LD context. So you are basically there as far as getting your data into a context broker and getting it out of a context broker. And a unrelated but similar level, if you have data well structured in a model, and you want to put that into a context broker, again, the thing to do is to make a pull request on Smart Data Model saying this is a industry standard, well used model for the data, and then you can use that as the basis of getting the data for the exchange, because it could be the case that you've got some JSON LD database system. They've got some database LD JSON system. You're just using the NGSI LD for the transport which is perfectly valid. You know, I hope you leave these sessions not thinking that a context broker is going to be a silver bullet which should be the entirety of your system. It isn't. It's a mechanism to make sure that there is interoperability and flow between the data components of your system. Is it possible to go the other way around? Instead of pushing the broker pulls the data in real time? Yes, that would be a registration. You would what you would happen is, and I showed an example of that which you would need to modify. I had a registration onto my proxy for an NGSI V2 broker. Fine. Now, what that was doing was whenever I made a request to my context broker, it would push, make a forwarded request to my V2 broker, which was behind it somewhere. In your case, it'd be a proxy, which would then access the data from your Json LD system. It would then get the stuff from the database, if necessary, tweak it a little bit so that it's valid NGSI LD, because the rules for NGSI LD are somewhat stricter than just random Json LD. Now, I'm assuming you've got a series of attributes. What would happen is that each attribute would have a value, potentially metadata like reserved at, but the value inside that is your data, which is where it's coming in, which means that if there was then a subscription on my context broker which said, give me the data for these entities in JSON format, key values format, sorry, not JSON format, key values format, it would actually effectively be your original data coming back out again. So you've got no data coming through. When a context provider raises some error, NGSI V2 always responds with 200 or data empty. It is difficult to find bugs for clients to be transparent, and the response is obfuscated. I think you're probably right. Obviously, the definition of the interface is clearer for NGSI LD than it is for NGSI V2, because NGSI LD is the ETSI standard. And for LD, if you have an error response, there is a standard format for that error response. But yeah, I mean, at the end of the day, what's going to happen is that if I have a context provider, I have some sort of data further down the system. If there's an error, it's that bit of data should be giving me something in the debug, something in the error messages to push the data elsewhere. So your context provider always returning a 200 OK is a bit strange, because you'd kind of expect it would actually give you something in the 400 series or 500 series, depending on where the error actually is. So I'd have to get more details off you to find out precisely what or which component you're talking about. Any further questions, folks? There was a question further back was saying, where can we find the slides used? The slide decks used will be, if they're not already published by the Fireware Foundation, will be published by the Fireware Foundation. Internally, there is a location where we hold our slide decks, which, as you probably guessed, I need regular maintenance and updating to make sure they are following the current standard. So what I could do again for that is I could give read-only access to the full set of slide decks. There are, in some cases, translations available in French and Japanese. But if you want to do other bits and pieces, yeah, okay, right. Fireware Marketplace initiative. I was giving presentation on the Fireware Summit in Gran Canaria back in September, and one of the sessions I was co-chairing with my colleague Julia was on the Fireware Marketplace. What's happened is that we've given greater prominence to the Fireware Marketplace. Actually, what I can do, just a minute, I'll just bring up the rules. I might as well just share. Just a minute, I'll just share my screen again. Right, I'll share the screen. So we're giving greater prominence to the products which are available, which are powered by Fireware, basically. There are products by category. You can search and you can find, devices. But if you're interested in this, you can look at the documentation and the submittal process. Now, the documentation basically describes how to make sure that your product gets passes the rules. It's actually not that difficult, because if you want to get into the Fireware Marketplace, chances are you are a Fireware system. However, we or the assessor can't just take your word for it. So usually there's a short meeting, walking through the product, working through the data flows of the product to basically convince the examiner that yes, you really do have a Fireware product. You shouldn't consider that as a negative, because whoever is assessing your product will be knowledgeable in Fireware. They will be able to discuss your architecture, think of things which might be of commercial use for you. I know I had a very long discussion with an application from AWS recently about ways they could potentially expand their system. Whether you take my advice or somebody else's advice or not, it's a commercial choice. Obviously, none of these things are necessarily make commercial sense. If they don't do them. But you will be given advice from a neutral third party who knows what they're talking about to explain what's going on. If you take an example, I could bring up one of the products within the Fireware Marketplace. You'll get details about the system. You can find out who the customer references are. You can find out more information about it, and obviously, effectively, it's an outlink to whichever product you're talking about out there. But this particular product is one of our more recent entries. It will have prominence in the Fireware Marketplace as a featured product for a while, and you can search for whichever system you want. So let's say we wanted to, I don't know, powered by Fireware. You can browse all, and let's say we want to find stuff which is to do with artificial intelligence. I think that's probably a technology. So yeah, so we can find out, okay, which products have we got which are artificial intelligence? Okay, well, Telefonica and NEC have got their products, but let's go for something which is not one of our platinum members. The table grabber here has got one which uses artificial machine learning for a price recommendation. Once again, you can find out the details as to what it is. So this is marketing information which hopefully should drive customers your direction. For further details, if anyone wants to contact me, I can put you with in contact with Julia, who is our marketing manager there. Her details, if I remember rightly, are actually on the marketplace itself at the bottom of the page. So if I just go back again, you'll find. There we go. You can just fill in the form at the bottom, and you will get in contact, and we can take it from there. Any further questions? If that's it for now, then I will. Before I close, I will ask one direct question from you. Is that have you started looking at the tutorials yourself? Because obviously, all of the learning materials I've been dealing with are available on the either FIWARE GitHub or the NGSI LD tutorials. Read the docs documentation. So if you want to find out, say, more about the CRUD operations, there is, there are a series of elements you can do, and you can get the data coming through. This is obviously a frequently changing system depending on what's actually coming through in the various specifications is being added to on a regular basis. There is more information on the FIWARE tutorials rather than NGSI LD tutorials, which also includes. Oops, I'm in the wrong place. Of course, it's not got concise. That's why. That's right. Just a minute. That's the problem when I type in the URL and go for the list. This has also got the sections on identity management and the use of some of the FIWARE components, like, say, for example, WireCloud, which would be the mashup, or Corrento, which would be a way of getting your devices. Right. One more question. On what principles do you separate FIWARE domain? Can you be more specific about that question, Andrew? Okay. Oh, you mean the various domains that? Okay, fine. I'll go back to fireware.org for a second. Right. You're right. It's tricky to try and separate literally everything by domain. I think we've got we define our domains here. These are our domain, in my opinion, is mainly customer related, so that they understand what we're talking about, rather than necessarily something which is a strict split. If you are looking at, say, the data model stuff, which Alberto was giving you, something like weather is literally cross domain. It makes no difference whatsoever as to whether you consider it as part of a city or part of a environment or part of a tourism initiative. So what it comes down to is the domain is what are the interested parties who would be getting data in this system. So obviously the obvious customer for smart city products is fairly clear, and it will kind of bleed into, say, smart energy if they're they're trying to get street lamps which are monitoring their street lamps, could be reducing their energy consumption. So yes, there is an overlap. It's more for education and marketing purposes that you would consider them as separate domains. When we look at the history of the FIWARE Foundation, initially the majority of context-driven products would be in smart cities. So smart cities would have been the original domain. But once there is sufficient momentum behind a particular group of companies or products, then it may, and there's enough people to try and build a community, it may well be pushed up to a full domain as far as FIWARE is concerned. Water is a good example of that. There was various initiatives at pushing water through or using a context broker to try and understand, flood warnings. Trying to work out potential flow through pipes and what have you. And because there was sufficient people of interest who understood that area, that became a proper domain for FIWARE. So hopefully that's briefly given the answer. Is there a component in FIWARE that allows to get data from Kafka and put it in Orion? Yes. You could do that in multiple different ways. I believe that there is there's nothing directly in the Fireware Catalog. In other words, the limited number of components which follow our rules, blah, 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 which does that yet. But I believe that there is a component created by Engineering of Italy, another of our Platinum members, which does precisely what you're after. There are also, you can build something like that using a NiFi flow, for example, or a Node-RED flow. So it is possible to get the data coming through in different areas. What I can do is I'll have a quick look back through my emails to find out which one it was, and I'll pass you the details of who my contact would be in that area, because this is the problem when we're trying to this is a problem we're trying to promote open source software, is that there's a lot of different things which we could different ways you can try and push this information out there, and wouldn't state that one particular way of doing it is necessarily the way to do it in all potential cases. So, there will be multiple ways which that could be done. Looking at the LD brokers, I think both Scorpio and Stelio use Kafka in the background as a mechanism for moving data around. So it's definitely possible. Andre's question, yes, you've got the idea. It looks strict because when you are trying to sell a concept, and we're trying to sell a universal interface for context data management, which obviously makes people's eyes glaze over. You need to kind of simplify what the message is. And it does help if you can say, this is a classic smart city scenario. There is a good example. There's a stop motion video we've got in smart mobility, explaining how you could use Fireware to work out how to make your day more pleasant by choosing various different choices in multimodal mobility. But we say, this is smart mobility. It's also smart city because obviously there's a massive overlap. But when you're trying to get the message across, you just pick the one and go with that. Yes, Scorpio does use Kafka in the background as to move the data around. But if you're looking to insert data, I think there are other components which you may be interested in. Anyone else? If there's no further questions, I will wish you all a Merry Christmas, except for Kevin, who I believe I'll be seeing in a couple of days' time. And I will wish him, and indeed Salome, Feliz Navidad, because I'm slowly learning a bit of Spanish. And if you've got any further questions, you know where to contact me, either within the Fireware Foundation or within LinkedIn. And I hope this has been informative, and wish you best of luck in improving your context-driven solutions using Fireware. Thank you very much.